So let's just do the first example. This is probably one of the more basic examples that you can do in this type of problem. We're going to evaluate sine cubed x cosine squared x dx. So this is what we're going to do. We're really going to turn this into a u substitution problem. We're going to use identities to do it. The trick is you want to pick the power that's odd. This is a rule that works when you're integrating a product of sine and cosine powers. So if you see something that looks like sine to the something times cosine to the something else, you want to look at the exponents and see if at least one of them is odd. If one of them is odd, or even if both of them are odd, you take either the odd power or one of the odd powers you can just pick, and you split off one factor of that trig function. So I'm going to rewrite this as the integral of sine squared x cosine squared x sine x dx. Now it doesn't look like this is going to help in any way, but I'll show you why it does. We're trying to turn this into a u substitution problem, and basically we want to make that a factor of du. So what I want to do is, since du is going to have a sine x, is going to have a sine x in it, what I want to do now is choose u equal to cosine x, and then du is going to be negative sine x. So that means that negative sine x dx. So sine x dx is equal to negative du. Okay, so it doesn't look like that's going to get us all the way there, but I'll show you how it does. What we want to do is take now this sine x and convert it entirely into cosine x. So this is now going to equal the integral of sine squared is 1 minus cosine squared. And then we still have the cosine squared x, and we still have the sine x dx. So this is nice because what we've done is we've been able to write this as negative du. This is u squared, and this is 1 minus u squared. So the integral is now going to be the integral of 1 minus u squared negative du. We'll do a little simplification here. We'll pull out the minus sign. Actually, let's not put out the minus sign. Let's rewrite it this way. Let's rewrite it as u squared minus 1 u squared du. This becomes integral of u to the fourth minus u squared du. And that's fairly easy to integrate, so this becomes u to the fifth over 5 minus u cubed over 3. Doing the back substitution, that gives us cosine to the fifth x over 5 minus cosine cubed x. Write that cubed a little nicer. Cosine cubed x over 3, and of course the hardest part of the problem, the plus c. And there we go. So that is how you'd evaluate this otherwise really ugly looking sort of an integral.